Hi everyone, and welcome to part 2 of our series on stoichiometry. In the previous video, we looked at this mole island diagram, this mole map, and how to potentially set up problems using this, because the whole concept of what we want to figure out in stoichiometry is a relationship between any two substances from a balanced equation. So let's dig into some examples and see how I'm going to use this mole map. Remember that you can pause these examples at any time and go back and rewind if something doesn't make sense. You also have the benefit in the margin over here to ask a question if something doesn't make sense to you. Okay, so write down any questions you have as you're doing these examples over here on the side. So let's do the first example. If 12.3 moles of KClO3 reacts, how many moles of oxygen will be formed? In my steps, the first step is I want to make sure my equation is balanced. I can see that there are coefficients there, so I'm assuming that the equation is balanced. So then I'm going to write down what I know from the problem. I know that I have 12.3 moles of KClO3, and I'm looking for moles of oxygen. I'm not concerned with the KCl at this point because it's just not asking for it in the problem, which is fine. So I'm going to set up my problem like this. I start with the 12.3 moles, and I'm going to write KClO3 after it. Then I need some sort of conversion. So I'm going to flip back to my mole map. Where am I starting on this mole map? I'm starting right here at moles because that's the unit that I was given in the problem. I wasn't given mass, volume, or particles. I was given moles. So then I can go right over here to moles of another substance. This was moles of KClO3, and this will be moles of O2. I can stop right here because that's the unit that I'm looking for. It's important here. I'm going to use these coefficients from the balanced equation. So I set that up in this step as a conversion. So from my balanced equation, I can see that 2 moles of KClO3 are needed to make 3 moles of O2. So now I can see that moles of KClO3 cancels out. It's important here to write the substance because you see the unit of moles 3 times. So which unit of moles has to cancel? That's why the substance after the word moles is going to be important. So then when I divide, I multiply 12.3 times 3 divided by 2, I get 18.5 moles of O2, and this is my answer. So I rephrased it down here. What that means is if you're starting with 12.3 moles of KClO3, you will make 18.5 moles of oxygen. Okay? Let's do another example. This time I'm going from grams to moles. If 4.53 grams of KClO3 reacts, how many moles of KCl will be formed? Let's look back on the mole map to see where I'm starting. This time I'm given grams of a known substance. So I'm starting here at mass. I need moles of an unknown substance. Like A and B are different things. So I have to get from mass to moles over to moles of something else. So that's my pathway that I'm going to follow. I set this up over here, so I have 4.53 grams, and I'm looking for moles of KCl. I start the problem always with what I know, so 4.53 grams of KClO3. I need one more step in my conversion here because these coefficients do not tell me anything about grams. They only tell me things about moles. So the conversion step that I need here is using molar mass. I've done the work of calculating the molar mass of these ahead of time, but you can pause the video and calculate the molar masses for the substances you need as well. but I'll fill them in here. So 1 mole of KClO3 is 122.6 grams. Then I include my mole ratio. So 2 moles KClO3, 2 moles of KCl on top. So grams KClO3 will cancel. Moles of KClO3 will cancel. And I'm going to be left with the unit of moles of KCl, which is what I'm looking for. When you take a minute and pause and do the calculation, you end up with 0.0370 or 3.70 times 10 to the minus 2 moles of KCl. Okay, and that's a small amount of moles, and that's okay because I didn't really have very many grams of KClO3 to start with. So my number of moles right here might not be super big. Okay. For example 3, I want to go grams to grams. I'll underline what I'm given. 8.26 grams of oxygen is produced. How many grams of KClO3 were used? This is what I'm looking for. 8.26 grams of oxygen is what I'm given. I don't know how many grams of KCl3 I needed. So here in my mole map, the unit that I'm starting with here is moles. I'm starting with mass up here, grams. I need to get over here to grams of something else, grams of a different substance. So I'm going to go from mass down to moles, over to moles, and up to mass over here. So that's a 3-step problem that I'm going to do. I can set it up. 8.26 grams of O2. 1 mole of O2 is 32.0 grams. I can set up my mole ratio. And then I'm going to need one more conversion with this problem because I need to get back over to grams. So 1 mole of KClO3. Oh, whoops, I did that wrong. My apologies. 1 mole of KClO3 is going to go on the bottom, and the molar mass of KClO3 is going to go on the top. If you caught that before I did, well done. So let's double check that our units really are canceling. So grams of O2 cancels, moles of O2 cancels, moles of KClO3 cancels, and I'm left with grams of KClO3, which again is what I was looking for in the problem. So now, again, you can pause, go through these calculations, and make sure you get the same thing that I do. When you punch all that in, you should get something close to 21.1 grams of KClO3. So what does that mean, once again? If 8.26 grams of oxygen is produced, this is how many grams of KClO3 I needed to produce that amount of oxygen. I had to go through molar masses for both substances, and of course using a mole ratio. That's the big concept here, is I cannot get to another substance without going through moles. Okay, let's look at one more example here with our conversions, because this uses something involving volume. So 12.2 grams of KClO3. How many liters of oxygen gas will be produced or will be formed? I haven't really used this conversion yet, but it is on your mole map, so let's bring it in now. I'll write down what I know, 12.2 grams of KClO3, and I'm looking for liters of oxygen. On my mole map, what am I given? I'm given grams, and I need to get over to volume. So mass, over here to moles, over here to moles, and then I need to go over here to volume. And that relationship that I use is 1 mole is 22.4 liters at STP. STP is standard temperature and pressure. So I'll set up the problem. 12.2 grams of KClO3. Then I've got my 1 mole of KClO3 and 22.6 grams. Do a mole ratio to switch substances. So that was 3 moles on top. Okay, so now 1 mole of O2 occupies 22.4 liters of space. It's important to note here that I can only do a volume conversion when I have a gas. And in this reaction, I know it doesn't tell me the states of matter, but I know that oxygen is a gas within this reaction. So that's why I can use 22.4 liters. If it wasn't a gas, I would not be able to do this conversion. So just keep that in mind. I'll make sure that my units cancel. I've got my moles of O2. Again, I can pause the video and make sure that you get the same answer as I do. So 3.34 liters of O2 gas. So that's another way of giving an amount. Instead of an amount of grams or particles or moles, I can also represent an amount using a volume. So 3.34 liters of oxygen would be formed. Okay. If there were any questions you had as you watch the video, those can be written down here, and you can sure ask me tomorrow in class. If you didn't have any questions, make sure you go back to these examples and review them on your own, and we'll do some more practice in class. Okay, thanks for watching, guys. Bye.